So now all the parts are printed, when we've got our two risers, sprue, surge tank I'll call it, and our gates into the part, which is apparently everything we need, plus some vents to add on. Let's glue it all together. Okay, now we've got our 3D printed model ready to go in our steel mold. Now it's time to mix some plaster. I've gone to my local hardware store and got some cheap fine casting plaster and some wash #1 sand, which I believe will do the trick. And we're going to mix it at a 2:1 to 0.7 ratio, with 2 of plaster, 1 of sand, 0.7 of water. It's not good that the scale's showing 0. Maybe in trouble here. Okay, big scale's not working. This one's a bit broken, but better than nothing. Not measuring milk, grams. We want 2.4 kgs. Sorry, 2.8 kgs. $280. Now 1.4 kgs of sand. Hey Kirby. How you doing, buddy? And 1 litre of water. And apparently the best way to do this is to put the powder into the water, not the other way around. I should have done this before weighing it, but too late now. The plaster starts setting after 10 minutes, so I have to be careful for time too. Very poor quality sand. Now, apparently the trick is to mix it slowly so you don't fill it with air. has not gone to plan at all. Can I fix this quickly? Fortunately the camera died and it was all panic stations with the mould setting, so I didn't have time to sort it. So I missed a bit of action there, but nothing important. It was all a panicked mess anyway. The biggest problem I had was that I did not make the 3D printed part strong enough, and the plaster with the weight behind it actually broke one of the hot glue joints. So next time I need to brace that a lot better with a couple of 2mm cross braces, or just by printing it in a bit better way. The second thing was the plaster sets in about 10 minutes, so while I quickly tried to fix it, the plaster started setting, so I'm not sure how good it's going to form to the finer details, and we may have a pretty shitty cast here. But as I said, we're going to push on. And the third thing I've realised is that I've left these open, which is mean I'm going to have to remove them once the plastic softens up, because this plaster has got inside. So in future I'm just going to make sure that I seal off these with caps to make sure it all burns out. So now we've got to leave it setting for 24 hours to let the water dry out, and then we'll start cooking it with a series where we start at 80 degrees, 150 degrees, just to warm it up, dry it, and then from 250 on we start melting out the plastic. And we'll raise it all the way up to 650 degrees to make sure it's completely burnt out, or best we can, and then we'll melt some aluminium and look at casting. I'll see you in 24 hours. Okay, we're back 24 hours later. Got my oven heating up, which I got for free with a broken latch. We're doing the first stage, which is an hour at 80 degrees. That is a lot heavier than I thought. Looks like our latching system has had an issue. So now we go from 80 degrees up to 150 for 2 hours. Now we're going up to 250 overnight, but I'm just going to see if I can get any of that plastic out. We're also going to be flipping it upside down. Okay, I couldn't leave it overnight, it was just too much risk, and also with free things you quite often have things that don't work, and without our latch I thought I could use tape, but that was a stupid idea because it gets hot. So as always, we've got a sophisticated solution, which is 2 screws and a bit of wire. That will do for now. Since I've let it cool down, I've got to build it back up to temperature slowly, then we'll continue with the 250 degree cycle and get it ready for the kiln. Flipped up the right way now, time to burn it off. Disaster has struck. My controller has just died at a prime time. I've done a heap of troubleshooting, and it turns out that the sensor, internal sensor which runs the K-type thermocouple has gone, but that's what that 000 error is determining in this case. But nothing's ever easy, but I'm determined to do this pour tonight. So what I have done is, you can see here, wired everything up direct, so I can manually control the kiln from the switch at the wall, and I have a cheap temperature sensor here So I should just be able to, for our burnout, which would have been a nice controlled burnout, now we're going to do heat it up to 600, turn it off, let it cool down to 500, turn it on, and I'll actually time this, and I can set an alarm on my phone so that I can just keep coming down every however long it ends up being to turn it off and on for 6 hours. So yeah, it really made my night, but as I said, I want to pour this tonight, so let's do it. Looks pretty cracked, but it's hard to tell how deep that goes. I did let the temperature creep up a couple of times, sort of to over 750, so that is definitely pushing the plaster past where it wants to be. While that cools down, our metal that will be melting is an old Kiln carburetor copy that never worked very well. It was a poor copy, so we're going to get our revenge by melting it down. Should be about the perfect amount. Crucible in the kiln, moulds preheating in the oven. We're going to heat the kiln up to 730 degrees, leave it for 10 minutes and pour. Okay, let's do this. First casting complete, and while the castings did not come out perfect, I'm definitely calling that a success. Learned a heap, which was the main thing I was trying to achieve, and also almost got, well, I think one is usable, one is not. So the three main problems I had first was the sand was really poor quality, and I've already found a local supplier that does pure silica sand for $13 a bag. So I'll be getting that for next time. Problem solved. Second problem was that I probably mixed the plaster a bit too firm, just needed a bit more water, which I think can easily be fixed again for next time. And third issue is, the main issue, is the remnants of the PLA ash that remained in the mould. And I believe that was caused for two reasons. The first being I didn't do the full burnout cycle because of my problems with the controller, and I think that contributed a bit, definitely. But the main problem was the mould design. It didn't let the ash or liquid PLA get out easily enough. So I think in future, the key there, just from what I've seen in this casting, is to design it so that most of the PLA can drain out in liquid form in that first 250 to 300 degrees phase, and leave as little as possible for the burnout phase, because especially in little products like this, to not get ash caught in certain areas is very difficult. So I've already got some ideas on how I'd redesign this mold to drain better, and I think it will be pretty effective. And it is very promising to see where areas like this, where the PLA was completely removed, the surface finish is brilliant. So if we can resolve this PLA ash issue, which I know is a common one for everyone, we should be able to get some pretty awesome products. And even with the detail on this being quite tricky for a first casting, very happy. So I've got some plans to make some new parts for both of my race bikes, and a lot of them going to be structural, so I need to start getting this pretty dialed in, and I'm confident we can do that. So if you want to see some more ambitious casting, subscribe, and I'll see you next time.